All right, so remember as we're doing this integration by parts homework that you're supposed to pick u based off of this Liate concept. So depending on which two types of functions you have, this helps you pick u. So I'll talk through that as we do this. These three problems, now that I look at this, it's kind of silly because I picked the same type of thing each time. We have the integral of x times e to the 2x. So identify for u and dv, but don't actually evaluate the integral, even though we could. So the rule here is that we have an algebraic expression and an exponential expression. So according to Liate, u should be the algebraic and dv should be the exponential. And same thing with all of these. So that's why I say this is kind of silly that I picked these. This is, again, x is algebraic. Secant squared is trig. According to Liate, algebraic is what you should pick for u before trig. So dv is going to be the secant squared x dx. And for the last one, again, x squared is algebraic. Cosine is trig. So same idea. U would be x squared. dv would be cosine x. So dx. So we're not actually going to do the integration with those. We're just practicing the setup very quickly before we go on to integration. So now for the next set, it says find the integral. Solve by the simplest method. So we don't have to do integration by parts. Remember, integration by parts is when you're doing the integral of a product and u sub wouldn't work. So consider u sub. Take a quick look for inverse trig. Does it look like 1 over a squared plus u squared, or 1 over square root of a squared minus u squared, etc.? Okay, so take a look at the first one. U sub wouldn't work. This is by parts because it is u sub would be u is negative 4x, du dx is negative 4. That's not going to cancel out the x here. So u sub doesn't work if the thing you're subbing in u for isn't 1 degree higher than what's out here. All right, so I'm going to use the tabular method. We talked about both in our notes. The tabular method is just a shorthand for what you get when you do the original definition. So it doesn't matter, and you can use either on the AP test. So tabular method is set up a u and a dv. I have an algebraic and an exponential. So u is going to be the algebraic. dv is going to be the exponential. Remember, you're taking derivatives of u and integrating dv. So when u is algebraic, that makes this really easy. You do as many derivatives as you need until you get 0. So the derivative of x is 1. The derivative of 1 is 0. So I'm done. I need to integrate that many times. So the integral of e to the negative 4x dx. Now, you need to get yourself to a place where you can kind of do this in your head, but I guess you could always do it off to the side. If I use u sub, I'm going to show the work without doing it in my head for this first one. If I use u sub on the exponent here, then du dx is negative 4, and we're going to have a negative 1/4 in our integral. So when we integrate this, we're going to have negative 1/4 e to the negative 4x. And that's going to repeat itself. If I integrate that, I'm going to have another negative 1/4. So that's going to be 1/16 e to the negative 4x. Okay, and then the tabular method is always set up like this. Next to the first row here, you have a positive, and then a negative, and then a positive. The u gets multiplied by the v, because remember the formula is u times v, minus, and then we multiply this, and then we loop this around. This is technically the integral of 0 times 1/16 e to the negative 4x dx, but that's going to be 0. So that's why this is nice, because it gets us straight to the answer. So what is the answer here? Multiply this stuff together. X times negative 1/4. So this is going to be negative 1/4 x e to the negative 4x. And then, wait, is it negative 4x or 4x? It's negative 4x. I think my answer key, I might have dropped the negatives, but it should be negative 4x. And then negative 1 times 1/16 is minus 1/16 e to the negative 4x. These are indefinite integrals, so we should have a plus c at the end. You can rewrite the negatives if you'd like. That's not required. For number 14, so again, don't forget about U sub and things like that, especially if this isn't initially looking like a product, it's looking like a quotient. So I'm going to think about U sub. If U is 1 over t, which it would have to be the exponent, du dt would be, this is t to the negative 1, so it'd be negative 1 over t squared. We have 1 over t squared, so yeah, U sub works in this one. It's not integration by parts. Negative t squared times du would equal dt. So instead of dt, we have negative t squared du. So the t squareds will cancel. So you've got negative integral e to the u du. And that's negative e to the u, which is 1 over t, plus c. For number 17, would u sub work? No, because if u is t plus 1, it's not going to cancel out the t that's the same degree. So this is by parts. We have an algebraic and a natural log. So by Liate, the u needs to be the natural log, and the other part needs to be the integral. So u is going to be natural log of t plus 1. The reason that's the rule is because we don't have any rules for integrating a natural log, but we do have a rule for taking the derivative of a natural log. Now, I'm not going to take derivatives until I get 0, because that's never going to happen with natural log. So for natural log, you're just going to do one round of this tabular method. So what's the derivative of natural log of t plus 1? 1 over t plus 1 times the derivative of t plus 1, so times 1. And then remember, you're integrating t. So what's the integral of t? So that's t squared over 2. And then we put in our plus and our minus. Multiply the diagonal and swoop this around. So this represents the integral of 1 over t plus 1 times t squared over 2. And I'm going to clean that up in a minute. Okay, so what do we have here? So this is just the tabular method. Is really just the formula version of the tabular method version of the formula, since we could only do one round. So this is equal to, I'm going to put the t squared over 2 out front. T squared over 2 times the natural log of t plus 1. And then minus, let's pull this, so we have a minus here, right? Let's pull this 1/2 out. So minus 1/2 times the integral of t squared over t plus 1 dt. Now we had this, I think, in homework number 2. We have something that's top heavy by 1 degree. So we should go ahead and divide it out to separate it so that we can integrate. Because right now u sub's not going to work, and I can't do anything algebraically besides division to simplify it. So let's do t plus 1 is dividing into t squared with some placeholders. You would multiply t by t to get t squared, and then it'll be plus t. Subtract that quantity, so 0 minus t is negative t. 0t minus t is negative t. 0, so t gets multiplied by minus 1. Subtract that quantity. The t's cancel, you get 0 plus 1. So this is plus 1 over t plus 1. Okay, so now we have t squared natural log of t plus 1 over 2 minus 1/2 times the integral of t minus 1 plus 1 over t plus 1 dt. This, I can integrate each one of those terms. There's technically a little u sub happening on t plus 1, but because du would be du dt would be 1, I don't need to make any adjustments there. So I can get right down to the antiderivative. So this is still here, t squared ln of t plus 1 all over 2. And then it's minus 1/2. I'm just going to put this in parentheses instead of distributing it through. The integral of t is t squared over 2. The integral of 1 is minus t. The integral of 1 over t plus 1 is plus ln absolute value t plus 1. Plus c for the indefinite integral. And that's our final answer. They don't always end up simplified and pretty looking. Okay, 28. We have something algebraic and we have something trig. And u sub is not going to work because the angle inside of the trig value is the same degree as what's out here. So nothing's going to cancel. So this is by parts. Don't know what I'm writing there. U and dv. U has to be the algebraic. dv has to be the trig. I love when you use algebraic because I know where to stop and I get right down to the final answer. So the derivative of x is 1. The derivative of 1 is 0. Done. The integral, remember you're integrating, the integral of sine x is negative cosine x. Do a quick check because the derivative of negative cosine x is positive sine. And then the integral of negative cosine is negative sine because the derivative of negative sine is negative cosine. All right, and then cross, loop, plus, minus, plus. The loop is the integral of 0 times sine x, so that's going to be 0. So our answer is negative x cosine x plus, because negative 1 times negative sine, plus sine x plus 0 plus c. All right. Number 30. Same idea. We have an algebraic and a trig. So the algebraic is x, or u is x squared, and dv is cosine x. The derivative of x squared is 2x. The derivative of 2x is 2. The derivative of 2 is 0. The integral of cosine is sine. The integral of sine is negative cosine. The integral of negative cosine is negative sine. Plus, minus, diagonal, 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 loop. The loop is going to be 0. So this is positive x squared times sine x minus 2x times negative cosine, so plus 2x times cosine x. Positive 2 times negative sine minus 2 sine x plus 0, so then plus c. $35. U sub wouldn't work at all for these because we have an exponential and a trig. According to Liate, u should be the trig. So u should be sine x, and dv should be e to the 2x. Now, how does this work with trig? So the rule with trig is that you should take as many derivatives as it takes to get back to a sine function, which should always be, you should have 3 rows here. So the derivative of sine is cosine, and then the derivative of cosine is negative sine. So I'm done at this point. And I'll explain why in a minute. And then remember, just like we did, so I'm not going to show the work for this now. We did this in the first one. When it was the integral of e to the negative 4x, what happened was I had a negative 1/4 out in front. So same thing is going to happen here. If I'm integrating e to the 2x, when I do u sub, I'm going to have a 1/2 e to the 2x at the end of that. Same thing again, you're going to have another 1/2, so now it's going to be 1/4 e to the 2x for that round. It's always plus, minus, plus. Connect the diagonals and loop around. So this loop is negative sine x times 1/4 e to the 2x. And we're going to clean that up too. All right, so what do we have so far? So we have, instead of 1/2, I'm just going to put e to the 2x over 2. Actually, I'm going to put, sometimes I think that it's hard to tell what's in a numerator and what's in a denominator, and I don't want a grader to misread my writing or anything. So although these are probably multiple choice, e to the 2x sine x over 2, and then it's minus e to the 2x cosine x over 4, and then it's, I'm going to pull a minus 1/4 out in front of this integral, e to the 2x sine x dx. So when you have an exponential and a trig, here's why you do the trig as many rounds as you need to get back to the original. Because this integral, see how it's the same integrand as here? So we can combine like terms. We can say, okay, we need to solve for this integral, so we're going to add 1/4 times this integral over to the other side. So 1 plus 1/4 is now 5/4 times the integral of e to the 2x sine x dx. This is like we did in the notes. And now all that's left over here are the terms that we had already gotten out of their integrals. And now to solve for this integral, I would need to get rid of the 5/4. So I'm going to multiply by 4/5. So 4 over 2 is 2/5. So 2 e to the 2x sine x over 5. 4's cancel out, minus e to the 2x cosine x over 5. I could, plus e. I could simplify those and combine if I want to, but it's really not necessary. So I'm just going to leave it like that. Number 37 is another exponential and a trig. So this is again by parts. So according to Liate, the trig needs to be u and the exponential needs to be dv. So cosine of 2x and e to the negative x. So again, this is trig for you. So take derivatives until you get back to cosine. So the derivative of cosine of 2x, don't forget about chain rule, it's -2 sine of 2x. And then the derivative of that is -4 cosine of 2x. And I'm back to cosine, so I'm stopping. When I integrate here, the integral of e to the negative x, u sub is going to put a negative in there. So negative e to the negative x, and then u sub is going to put another negative in there, so now it's positive e to the negative x. Plus, minus, plus, connect diagonals, loop around. This is now the integral of -4 e to the negative x cosine 2x. So see how the same thing is happening as before. All right, so what do we have here? We have negative e to the negative x cosine of 2x. Now you can rewrite your e to the negative x's if you'd like. Again, it doesn't matter because we're not actually doing anything solving with these, so you could also just leave it like this. And then let's see, we have negative, negative, so positive 2 e to the negative x sine 2x. And then minus, I'm pulling the constant out, 4 integral of e to the negative x cosine of 2x dx. And just like I did on the last one, I need to add this integral over to the other side. So 1 plus 4 is now 5 times the integral of e to the negative x cosine 2x. And that's equal to, let's go ahead and factor out an e to the negative x. Why not? Just to show you what that would look like. I'm going to put the 2 sine 2x first and then the minus cosine 2x second. Again, that's just personal preference there. There is a plus c happening, but I'm just going to add that at the end. Divide by 5. So 2 sine 2x minus cosine 2x. Let's put the e to the x down there in the 5. So 5 e to the x, and there's a plus c. If you put the plus c in early, just remember anything algebraic you're doing does not apply to the plus c. All right, 38. We have, again, an exponential and a trig. So let's let u equal cosine of 4x, and dv will equal e to the 3x. So I'm going to do the derivative of cosine 4x is -4 sine 4x. The derivative of that is -16 cosine 4x. So I stopped there because I got back to cosine. When you use u sub on 3x here, you're going to get 1/3 e to the 3x. And then you're going to get 1/9 e to the 3x when you integrate. Plus, minus, plus, connect diagonals, loop around. This is going to be the integral of negative 16 ninths e to the 3x cosine 4x. Okay, so this is e to the 3x cosine 4x over 3. And then minus negative, so plus 4 ninths e to the 3x sine of 4x. Just extend that there. Minus 16 ninths times the integral of e to the 3x cosine 4x dx. You're going to add 16 ninths times the integral to the other side. So hopefully, the last three have been like this, so hopefully you are picking up on the pattern. Maybe even carefully skipping steps would be fine with me. I'm just writing out everything I have. Okay, and then to get rid of 16 ninths, I'm going to multiply by 9 sixteenths. Just checking my work along the way. I think I'm okay so far. Okay, so let's see. So this is going to be, oh wait, now why do I have 20? I have 9/25 somewhere. Am I just going crazy? Oh, whoops. Yes, I am going crazy. Okay, because 16 ninths, I had to add that to 1. I forgot to do that. 1 plus 16 ninths. 9 ninths plus 16 ninths is 25 ninths. There we go. It's good to show that, right? That'd be an easy thing to do. So then we're going to multiply by 9/25 to get rid of that. Okay, so 9 over 3 is 3. E to the 3x cosine 4x, and it'll be over 25. And then 9 over 9 cancels. So we're going to have 4 e to the 3x sine of 4x, and that will be over 25. And then there's a plus c on the end. Okay. Solve the differential equation. The reason I include the instructions beyond just so that I can see what I'm supposed to do is part of how you should be studying for calculus is studying what the directions say and then like what you're supposed to do. So solve the differential equation means this y prime is really dy dx. So you need to separate, integrate, celebrate. All right, so separate, I'm going to put dx over here. So I have cosine y dy. So y's are together. 2x equals 2x dx. Integrate. We can integrate cosine. It's sine of y is equal to 2x squared over 2 plus c. How do I get rid of a sine? I take the arc sine or inverse sine of both sides. Remember, that doesn't apply. I guess I did put it in the c there, but the plus c could be on the outside too. That's interesting. I guess if I had an initial condition, I would plug it in back on this step because this always kind of perplexes me of like, do I include it or not? I'm going to include it like I did on if I had the initial condition, the plus c would get included as I'm solving here. So I'm going to put it in. This is where if I had a point that I had to satisfy, I'd plug it in here before I took the arc sine on both sides. Okay, anyway, so that's y equals the arc sine of x squared plus c. All right, for this section, evaluate the definite integral, use a graphing utility to confirm your result. I guess I didn't really do that on my answer key, but I think that's okay. So again, this is going to be an algebraic and an exponential, so we love those. So that makes u the algebraic and dv is the exponential. Take derivatives until you get 0. And then here, when I do u sub, so when it was 2x, if this were 2x, I'd have a 1/2 e to the x over 2, or e to the 2x. If it's x over 2, you're going to be dividing by 1/2, so you're going to get 2 e to the x over 2. Right? So when these were, let me go back and show this. When this was 3x, I had a 1/3 out here. So if the exponent has a fraction in it, you're going to have the reciprocal of that out here. And this is going to be 4 e to the x over 2. Plus, minus, plus, diagonal, diagonal, connect. This is an integral of 0. So my answer is 2x e to the x over 2 minus 4 e to the x over 2. And we're evaluating, I was going to do plus c, but we're evaluating from 0 to 3. So put in 3, you get 6 e to the 3 over 2 minus 4 e to the 3 over 2. And then put in 0, you get 0 for the first term, minus 4 e to the 0. These are like terms, so 2 e to the 3 over 2 plus 4. And I don't want to take the time to check on my calculator, but I could and then see if the decimal version of that is the same. All right, number 66. Use the tabular method. Oops, we've been doing that all along to find the integral. Now, these are two algebraic pieces, right? They're both algebraic. So how do you decide if it says, if we're using Liate? I would say that it'll be easier to get the x, it'll be easy to get the x squared to get down to 0, so we'll have a stopping point. And we wouldn't get down to 0 otherwise. So that's how you know, even though they're both algebraic, you pick the one that's going to get down to 0. So x squared versus x minus 2 to the 3 halves. So this will be 2x, 2, 0. Now when I integrate this, okay, so we're going to be adding 1 to our exponent, so x minus 2 to the 5 halves. And then we're dividing by that new exponent, so we're really multiplying by 2/5. And the u sub would not be relevant because u would be x minus 2 and du dx would be 1. So I don't have to worry about that. Okay, and then what are we going to have after that? Now the x minus 2 is going to be to the 7 halves power because I added 2 over 2, or added 1. Now you're dividing by 7 halves or multiplying by 2/7. So now this is 4 over 35, which is ugly. And we have to do one more round of this. X minus 2 to the 9 halves. So 4/35 times 2/9. So 4 over 2 is 2. 35 times 9, I don't know. That's, let's see, that's 45. 27 plus 4 is 315. Okay. Now why did I have, hold on, 4 over 35 times what I get for not writing it out. Oops, that doesn't cancel. That's just 8. Sorry, 8 over 315. I should have written that down, but I was trying to be fast and I just shouldn't have done that. So plus, minus, diagonal, 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 loop. Careful with those diagonals that you have it corrected, written down correctly. So 2x squared times x minus 2 to the 5 halves. That's all over 5. Next one is minus 2x times 4 is 8x times x minus 2 to the 7 halves over 35. All right, and then we have 2 times 8, so, and it's plus 16 times x minus 2 to the 9 halves over 315. And this is an indefinite integral, so plus c. All right, what about number 83? Integrate this by parts and then by substitution, and they tell you what to let dv equal. So, okay, let's do by parts first. So that's Liate. So u and dv. So they tell me to let dv be this. That means u is this, which is what I would have chosen on my own, so that's good. And then we could get, let's see, 2 1. And then if I, no, what? The integral of 2x is 2. The integral of 2 is 0. And then if I integrate 2x minus 3, so this is 2x minus 3 to the 1/2 power. So first of all, I'm going to have 2x minus 3 to the, when I add 1, to the 3/2. And then there will be a times 2/3. This does have a u sub. U is 2x minus 3. So du dx would be 2. So there's going to be a 1/2 out there too. So that's 1/3 times 2x minus 3 to the 3/2. Let's do that again. 2x minus 3 will now be to the 5/2, which means the 1/3 that's out there will get multiplied by 2/5 and also by 1/2 because of u sub again. So that's 1/15 times 2x minus 3 to the 5/2. Okay, and let's see, plus, minus, plus. Diagonal, diagonal, connect. So the integral of 2x radical 2x minus 3 dx comes out to 2x times 1/3. Well, let's see, 2x times 2x minus 3 to the 3/2 over 3 minus 2/15 times 2x minus 3 to the 5/2 plus c. Let's see, did I do that when I got this first thing? Yeah, that's what I got. Okay, good. So then for part B, do this by substitution, and they're telling you how to u sub. So if that's the case, if u is equal to 2x minus 3, then du dx is equal to 2. So du over 2 will be dx. So let's set up what we have. Now that's not going to cancel out the 2x. So remember the trick we have? Instead of 2x, u plus 3 can equal 2x. So I have u plus 3 in place of the 2x. I have square root of u because of the u sub. And then instead of dx, I have du over 2. And so that can pull a 1/2 out here. We can distribute this through. So u to the first times u to the 1/2 is u to the 3/2. My pen just ran out. Hold on. So that's u to the 3/2 plus 3u to the 1/2 du. And that is 1/2 times u to the 5/2 times 2/5 plus 3 times u to the 3/2 times 2/3 plus c. Clean this up and get our u's out of there. So u was 2x minus 3 to the 5/2 over, so these 2's will cancel, over 5. And then the 3's here cancel, and the 2's are going to cancel. So plus, oops, not u, 2x minus 3 to the 3/2 over nothing, as far as I can see, plus c. Now, this is not the exact same answer that I got. Let me check my key. 1/5. Yeah. So, again, for length of the video, I don't want to do it, but you can go ahead and type both of these, not the plus c, but type both of these into Desmos, and you do get the same graph. They're equivalent to each other. I think they come out to the exact same graph, but if they didn't, they would be vertical shifts of each other as well. But I think they come out to the exact same thing. I believe I checked that. All right, and our last problem, but it's a bit of a throwback here to chapter 7. So given the region bounded by y equals ln x, y equals 0, and x equals e, find the area and then the volume revolving around the x-axis and then the volume around the y-axis. So let's draw this thing first. So part A, area of the region. All right, y equals natural log of x. I know that that goes through 0, 1, does one of these, and we're bounding it by y equals 0 and x equals e. And when I plug in e into natural log x, I get 1 for the y value. Okay, so this area is just this section here. So the area should just be the integral of top minus bottom, the integral from 1 to e of natural log x dx. And remember, we don't know how to integrate natural log x, but we now have integration by parts. So how does this work? Liate says that u has to be natural log x. And what does that leave for dv? It only leaves dx, or you could say like 1 dx if you want to. The rule with natural log is that you only do one round of derivatives. That means I integrate 1 dx and I get x. This is going to be the integral of 1 over x times x. So now we have x times natural log x. That's not in an integral anymore, so it'll get evaluated from 1 to e. And then we have minus the integral of 1 over x times x just cancels, so dx. And that's still going from 1 to e. If I plug e into this, I get e ln e minus 1 ln 1. Figure that out later. Minus x evaluated from 1 to e. ln e is 1, so this is e. ln 1 is 0, so that's gone. Minus e minus negative 1, so plus 1. So all of that to say the area is 1. That's kind of cool. What about the volume of the solid generated by revolving the region about the x-axis? So for part B, take this region here from 1 to e, this guy, and spin it around the x-axis. This is a dome method, or what is it, disk method. Your r is still just equal to ln x. Remember the volume formula, though, is pi r squared. So pi times the integral from 1 to e of ln x, the quantity squared, dx. And that's pretty tricky too, because again, we can't just use u sub. That's not going to work. So when we do Liate, we have to let u equal ln x squared. And I'm looking at my time. I feel like I'm going to get cut off right before the next class starts. So we'll see how this goes. So what's the derivative of this? This derivative is 2 ln x times 1 over x. And then the integral of dx is x plus minus, boom, boom. This will be the integral of 2 ln x times 1 over x times x. All right, so we have pi. Don't forget about the pi. X ln x squared. That goes from e to 1. And there's a pi out. This pi will get distributed through. Minus 2 pi times the integral of those x's cancel. So ln x dx. Now, we just, from 1 to e. I'm going to use a shortcut here because we just did this. We just figured out what this answer was for this part. It's 1. So that's kind of nice. So pi times e times ln e squared minus 1 times 0 squared minus 2 pi times 1. That's pi times e minus pi minus 2 pi. I'm getting pi e minus 3 pi. I think I either messed up somewhere in my work on my key or I messed up in my work somewhere here. I had pi e minus 2 pi. So I either messed up here. Oh, wait, did I mess up here? Yeah, because this is 0. There we go. Boop, boop. Minus 0. So that's 2 pi. There we go. All right, and I do have time. Okay, so I have time for the last part. So part C is same region, revolve, 1 to E, revolve around the y-axis. So you have an outer R and you have an inner R, but they're going sideways. So instead of y equals ln x, e to the y equals x. So the outer part is just, the big R is e minus 0. The inner part is e to the y minus 0. Washer method is the integral from 1, not from 1 to e though, from 0 to 1. Remember the y bounds that I established back here? So the integral from 0 to 1 of pi times capital R squared, e squared dy, excuse me, minus pi times the integral from 0 to 1 of e to the y squared, e to the 2y dy. This is pi e squared times times y. Integral of a constant is y from 1 to 0. Minus, this is going to have that little u substitution. There's going to be a 1/2 there, and then it'll be e to the 2y from 0 to 1. So this is pi e squared times 1 minus pi e squared times 0, so pi e squared, minus pi over 2 times e squared minus e to the 0, pi e squared minus pi over 2 e squared plus pi over 2. That seems like pi over 2 e squared, if I combine those like terms, plus pi over 2. And checking my answer key, that's what I had. So yay. Okay, that was a challenging assignment for sure. Again, my advice with using integration by parts is to study the types. You only have a few types of scenarios that you're going to run into. Study what you do in those situations, like if U is algebraic versus ln versus trig.